of very large database is that the total size of the database is measured in gigabytes or even terabytes, but it doesn't show us the individual table size. So for the large table is one that doesn't perform as expected, or where the maintenance cost goes beyond the predefined maintenance periods. So also the table can be considered large if one user's activity is significantly affecting another, or if maintenance operations affect other users' operations. So this even may limit availability. So even though the server is available, so how you can consider that your database available? For example, when your sales table's performance is deprecated or even inaccessible during maintenance for 2 hours per day or even per week. So in some cases, periodic downtime is acceptable, but still you need to have a better design to minimize for these downtimes. So for example, for your sales table, as I said, the current month's data is read-write, and the previous month's data is mostly the large part of the table is read-only. So large table maintenance overhead can limit the table's ability to respond to user requests. So also performing the maintenance operations on data will be costly, even we don't need it. So also, and the cost can be seen in performance problems. So floppy problems for backup, space problem, time problem, and operation cost problem. So as well as the negatively impacting in overall scalability of SQL Server. So how can partitioning help? So when tables and indexes become very large, partitioning can help by splitting large amounts of data into smaller, more manageable pieces, more small partitions. I mean, with partitioning, large amount of rows will be stored in multiple separate partitions. So partitioning a large table divides the table and it is indexes on its smaller partitions, so that the maintenance operations can be applied on a partition by partition basis. So instead of the entire table. So in addition, SQL Server Optimizer can direct properly filter the queries to appropriate partitions, so instead of the entire table. So if we talk about the benefit, so I can say partitioned large tables or indexes can have manageability and performance benefits, and you can transfer or access the data quickly and efficiently. And for example, an operation such as loading data from the OLTP to an OLAP system takes very quickly, instead of hours the operations takes when the data is not partitioned. And you can perform maintenance operations on one or more partitions more quickly. The operations are more efficient because they target only these data subset instead of the whole table. For example, you can choose to compress data in one or more partitions or attribute one or more partitions of an index. So you may improve query performance. Of course, it is also based on your hardware configuration and based on the type of queries you frequently run. And for example, the query optimizer can process between 2 or more partition tables faster when the partitioning columns in the tables are the same. So because the partitions themselves can be joined, so when SQL Server performs data sorting for all operations, it sorts the data first by partition. So to improve data sorting performance, struct the data files to your partitioning across more than one disk. So in this way, SQL Server can access all the drives of each partition at the same time. So in addition to that, and you can also improve performance by enabling clock escalation at the partition level instead of all table. So this can reduce log contention on the table. It will be reducing log contention on the table. For planning table partitioning, so in order to successfully partition a large table, you must make a number of decisions. So we should take decisions. So we should plan partitioning for For example, you should decide which table or tables can benefit from the increased manageability and availability of this partitioning. And you should decide column or column combination on which column to base the partition. So you should also specify the partition boundaries in a partition function and plan how to store the partitions in file groups and using this partitioning schema. So as I already mentioned, so any large table has maintenance costs that exceed its requirements or that's not performing as expected due to its size, so not be a candidate for partitioning. But the other options, other conditions to select the partition table, so index maintenance on the table is costly or is taking time consuming and could benefit from index partitions of the table rather than all table at once. So your data may be aged, so data must be aged out of the table periodically, and the delete process is taking too slow, currently too slow, or blocks user and trying to query the table. And the new data is loaded periodically into this table, and the load process is too slow, and the table data length itself the partition columns and based on this ascending date or time. So in other words, so we should make sure that large table will actually get benefit from partitioning. For after we deciding partitioning, so we should decide the partition column. So after decide the table could benefit from partition, then you need to determine the partition columns. The partition column stores the values on which you want to partition the table. The partition column choice is critical because after you have partitioned a table, choosing a different partition column will require recreating the table. So reloading all the data and rebuilding all the indexes for the partitioning column. In a cluster table, the partition column must be part of either the primary key or the clustered index. Because if the partition column is not part of the primary key, the partition column may allow null value. So any data with a null in the partition column will reside in the leftmost partition. And also the partition column should reflect the best way of subdivide the target table. So also you should look for a balanced distribution for your data, for balanced distribution of data for the partitions. And you should also try to choose the partitioned columns that will be used as a filter criteria in most of the queries run against this table. And this enables partition elimination, where the query processor can eliminate inapplicable partitions from the query plan and just access the partitions implied by the filter on the query. So after you have identified the table, it's a partition column, then you can create or use an existing partition function that set off the correct range boundaries for function, and you can create or use an existing partition schema on partition function, and you can create the table using the partition schema. So you use the data type of the partition columns when defining the partition function. So effectively, you must choose the partition column before defining the partition function, or deciding which partition function to use. So if you have field available, then you must choose the partition column. So before partitioning function. So this is you should prepare your partitioning in this way. So if I explaining partitioning components, table partitioning components, so we will be looking components details in following slides. So I'll just give you a brief info here for partition function. So the partition function defines the boundary values of initial set of partitions and the data type of partition column. So it doesn't make any reference to any table or disk storage. It is just form a basis for partition schema. And partition schema maps the particular partitions to the file groups. And given partition schema can be used for one or more partition tables, indexes and indexed views. And the partition table or index, So we can use in a particular partition or particular partition schema when it is created. So the relationship between this partition function and partition schema is one-to-many. So you can have, so as the relationship between the partition schema and partition tables and indexes is the same. So however, in a practice, because of moving data in and out from the partitioning table, we may move the data in and out. So a table usually requires modifying this partitioning function. And usually a partition table is dedicated to the partition function and the partition schema. So for the details, for partition function, so in order to choose the best partition columns for a table, so it's critical to understand how the partition function works, because the partition function includes a data type that must be the same data type as the table's partitioning column. Partition functions are stored within the database you create them in, but they are not the same as user-defined functions. So instead, they are special objects used only with table partitioning. So partition functions are not listed as database objects. So although user-created, as I said, so they are different than from user-defined functions, and they don't list in the database objects for sys.all users objects table, sys objects table, system table. And instead of, you can find them listed in the table sys.partition_functions table. And partition functions also are not contained by a database schema. And partition functions can be invoked by, you can use the $sign and partition as a function to use the partitioning function. And you create the partitioning function with the create partitioning function statement. And you can give input parameters for declaring the data type of partition boundaries. You need to define these partition boundaries. And the input parameter must be compatible with the table partition column, as I told you earlier. It must be the same type. And you should define the range type either left or right. So when you specify the boundary values in the partition function, so it will be put to resulting partitions, it will be effective partitioning. And so the set of you should set up constants for the boundary value. So it will the boundary points must have the same data type as well. So I will show it in visual functions. So you specify a set boundary values from a range of possible values of the input parameters data type. So these boundary values define a number of sub-ranges within an overall range. So they call it partitions this time. So I'm showing you now the partition functions. We have an integer data. We have a dividing range of integers. And I will cut it to value 10. So it's our range, it's our data, and should change actually. Okay. So I am using partitioning function for the range left. So range left means that the boundary values falls the partition to the left. So partition also now have limits placed on their ranges. So range left will one partition boundary, it will show us. And the boundary value specify the upper bound of its partition 10. So 10 is highest available value in partition 1. If I show it this way, so if we run this query, create partitioning, it will be like this, with range left. And 10, as I said, 10 is the highest available value in partition 1. And all values in partition 1 must be less than or equal the upper boundary of partition 1. And all values in partition 2 and must be greater than partition 1's upper boundary, which is 10. So let me move to other slide. Then I will show the right one. So we have a same clicking. So this time I will use the range light and put boundary value 10 into partition as it is right. And this one again. Then range right means, as you can see, it's different. Then 10 is on the right side. So the boundary value shows the partition on the right, but different limits now exist on partition values. So range right with one boundary value, it will show us that for the range right, the position 10 is now the lowest available acceptable value in partition 2, right? So all the values in partition 1 must be less than lower boundary 10 of partition 2. So the maximum value will be 9. So also the partition 2 must be greater or equal than partition 2's lower boundary. So which is 10. It will be. So can you hear me? Anybody can reply me if you can hear me. Okay, I think someone said that he cannot hear me, so I wanted to make sure. Okay, so you can hear me fine. So okay, for both and range left and range right, and the leftmost partition has the minimum value of the data type as it is lower limit, and the rightmost partition has the maximum value. It will be maximum value of the data type as it is upper limit. So I hope I explained clearly. So for partitioning function, you can use with $. So you can determine where a partition function will place values by using the partition $, system function. And partition calls the user-defined partition function where the partition function is passed the sample data value as an input parameter. And based on the range direction, left or right, and the boundary values, it returns a result indicating what partitions a particular value. So on this example, you can see the result for select star partition PF1 on left, so it will be in partition 1, and the select $sign partition PF1 right, then it will be in partition 2. So for the partition schema, the next step after defining a partition function is to map the partition function to one or more partition schemas. The partition schema defines how any resulting partitions will be stored on 5 groups. So you list the 5 groups for a partition schema in the same order that you want to have them mapped to the partitions defined by the partition functions. Creating a partition schema assumes that you have already created the 5 groups. Assuming 5 groups have been created, so this code on the screen I can show to you: 5 group 1, 5 group 2, 5 group 3, and 5 group 4. And code defines 5 groups for the PF2 right with 3 boundary values. I can say 0, 10, and 20. And so when we run this to 5 group 1, 5 group 2, and create a partition schema, SQL Server accordingly assigns the first partition to 5 group 1 and the second to 5 group 2, and so on for all 4 partitions. If you want to place all the partitions on a single 5 group, you can type all keyword on here instead of defining the 5 group names. All keyword, and you can place all partitions on the database's primary 5 group using the primary keyword. So you must provide a sufficient number of 5 groups to handle all of the partition function partitions. So if you supply more file groups than there are partitions defined in the partition function, then SQL Server will mark to use it for next use. So after the exit partitions are met, it will be used next use. So next file group to use if the number of partitions increases. SQL Server only keeps the track of the existing mapped file groups and the single file group designated with the next use command. Otherwise, we don't see it. So, like a partitioning function, also the partition schema is a metadata object, and no actual table partitions exist until a table is created referencing this partition schema. It will not be available and it will not be shown in sys objects. I'm trying to see the other. I think some of them still cannot hear me, but I will continue. For the partition table and indexes, so we define partition schema, and after we define the partition function and partition schema, we can put them to their intended use by partitioning a table. The partition function defines the boundary values and the range direction, and the partition schema assigns those partitions to file groups for the disk storage. So after adding files to file groups, we are ready to create the partition table. To partition a table, we must put the table on partition schema. Okay, so we can do this by creating the table on the partition schema, or we can do this by creating the table's clustered index on this partition schema. So you can see create table, partition table on the partitioning schema. So to partition the table, we must put the table on a partition schema, as I said. So, and the create table, partition table, you will see it here, partition column ID, and on PS2 right. So in this on clause here, and you specify the partition schema to use and the column of the table that will serve as a partition column, so which is partition column ID. And if the table already exists, there are a couple of ways to partition, because if it doesn't exist, you can easily put it on schema, then it will be easier. And if your table is already exist, then you can drop all the indexes except the clustered index, and you can attribute the clustered index on the partition schema. And as you can see on the screen, then you can recreate your non-clustered indexes later on. And also, you can use the alter table function. And so, as I said, the partition table can be a heap, or it can have a clustered index. So if you start with the heap, you can add the clustered index later and specify the partition schema in on class like this one. And if the cluster key does not contain the partition column, so what will happen? So SQL Server will add it internally. It will use this cluster key internally, automatically it will add it. So if you create the partition table specifying without a partition schema, the table will still be created and it will be on default file group or other file group that you defined. So then you can partition the table by creating a cluster index that identifies the partition schema, and the same way that you created create table. So it will be easier. So also, in addition to that, and then you should place a check constraint on the table to exclude partition columns values that to put outside acceptable ranges, so that the partitions at the extreme left and right will not contain unusual partition column values. So here I would like to show you a demo. We'll try to share my screen. Can you see my screen right now for my? Because I'm trying to share the desktop. Okay, let me try to share full desktop here. Cancel this one. Okay, sorry. I just shared the application, so it looks like it doesn't work very well. So I'm going to share all my desktop. I will select all. I hope you can see it right now. Can you? Okay, great. Different colors. Okay, so I'm going to show you a demo. I'm going to create a tables for TestDB to make a partitioning. And so first of all, I'm going to create the database for it under C TestDB partitions. And it's completed, and I'm going to use the TestDB for my operations. So here, after creating the database, I'm creating the partition functions. So as I already mentioned many times, so it is an algorithm. It's an algorithm for your particular implementations for table partitioning. So when you create a function, you specify so what data type the object will be partitioned on. So I will be defining here. So I'm showing it is on integer value. When you create a partition function, so also it is really important to know, so I will set it here, range left, but it is important to know the range is right or range because it is up to what data type is used for. For example, for date time columns, so there's a recommendation to use range right. So the partition boundary values will be the lower boundary values. So for integer, I will use left, but please check the recommendation values for left or right. So I created the function, so also created the partition schema. So for this partition schema, how do I get to my partition functions to understand my file groups? So in order to do that, so I am creating this partition schema. So I created it. So I would like to create a table for this one. So I'm going to create a table, and so it's a heap table without any index, so I will create it later on. So here, so as I'm creating the index, and here, so I am placing my partition schema, and when I do that, here, the schema on the table, and when I do that, I am partitioning the ID column, which is integer 2, and its merge is what I defined in my partitioning function in up. So I'm adding the cluster key, cluster index here. And now I am going to insert some rows. It's just a for row to show it. So it is the rows was 1, 10, values 11 and 12. So it will be in partition 1, partition 2, partition 2. So let's check our tables. Just 1, 10, 11. And let's check the partition configuration with this $sign partition. And you can see the partition number 1, minimum ID is 1 to 10, and the rows in the partition is 2. And for partition number 2, minimum ID is 11 and maximum ID is 12 because I only inserted 11 and 12, and the rows in a partition is the same for this one. So let me go back my presentation. Sorry, again. So I'm just checking here. You can see which one. Try to move. Sorry for partitioning demo. And also, so I should mention about the data movement. You can use split, merge, and switch operations. And partitioning functions are not static, so they can change over time, and their changes through the partition schema to the partition table. You can alter a partition function to change the boundary value list, one value at a time, and the method that makes it possible to add and remove new partitions. As I mentioned earlier, you cannot change the partition function's data type or range direction. So you can just change the boundary values. To do this, you can use split and merge to change the partition functions. Also, you can use switch operations for the partitioning. And for partitioning, for switch, and you can, so here for the switch, so you can add single boundary value using the split. So it's a split keyword, you can add a single boundary value using the split keyword in an alter partition function. And before doing this, you should make sure that the new boundary value must be in the allowed range and distinct from the existing boundary values. And adding a boundary value has the effect of splitting the table partition that the new boundary value should be in to fill in. And the new boundary value should support the range dilations specifying create partitioning function and left or right. And if the partition function is used by a partition table and split resulting partitions, then where both will be contained data. So SQL Server will move the data to new partition. This data movement will cause, so it will be moved to other partition function. So the data movement also will cause transaction log growth due to the insert or deletes. So for example, we have the data here. So I'm calling the pfWrite partition function, which is currently has the boundary values is 0, 10, 20, and therefore has a set of partition is 1 to 9, 10 to 19, and 20 and max. And now I'm changing this and adding and split range to 15. So what will be the result now? The result will be now we will have the four boundary values, 0, 10, 15, and 20, and therefore 5 partitions we will have. So the new partition beginning with the 15 is now partition 4, and the old partition 4, so now it is 20 months, that gets renumbered as a partition 5. So in this example, inserting the boundary values 15, we'll move the any data with values from 15 to 19 into new partition 4, and it will contains all the data between the 15 and 14. So it will be partition 4, and the 20 will change as a partition 5 for the split operations. For the merge, so we still have same. So similarly, again, same. You can remove a single boundary values using merge, and you can removing the boundary values has the effect of merging two neighborhood partitions, neighbor partitions, into a single new partition. And removing the boundary values reduces the total number of boundary values by 1. So also, therefore, the number of partitions by 1 will be reduced. So, for example, suppose you remove the boundary value 10 in PF2 right here, and you will remove the 10. So we are merging range to 10. So this is the currently value 0, 10, 10, 14, and it will be 15, 19. And after this, after merging, then this commands it will partition with lower boundary 10. Then now it is the 0 to 14, 15 to 19, and 20 and max. So you can check the results by using this partition $sign function with the sample values, or by querying this metadata. So now we now have 4 partitions, because the boundary values for partitions 3, the boundary partition 3 was removed. So the old partition 4 and 5 get renumbered, and the partition 3 and 4 as 4 and 5, it gets the partition 3 as partition 4. So we can remove all this. We can use the merge function, and we can remove all these boundaries from the partition function. So the result will be a partition function with only one partition 1. So because the partition function has no boundary values, so it will have no rows in this partition range values system tables. For the switch operations, and for if a partition table uses a partition function, okay, referencing the schema, then you can use split and merge operations on the partition function. So it will cause the SQL Server to redistribute the data. As I showed you, it will be moved on partition 1, or it will be move it to partition 2. So it will redistribute and transfer the data. So for the split operation, partition data and index is all redistributed between the all existing partition and the new one. And for merge, the data and indexes will be consolidated, will be merged from 2 partitions into a 1 partition. And for partition table, so also with the significant amount of data, if you have a significant amount of data, so this data movement, it will be costly. It may take time, and you may take time. It will take time to move the data. So to avoid of this data movement, SQL Server provides a switch option. So switch option on the alter table statement, you can use it, and it allows you to play the partition table. So the split and merge will only operate the empty partitions. You can only use them for the empty partitions. And resulting split and merge operations, then it will become a simply metadata operation. Also, the switch statement itself is only the metadata operation, so it also happens immediately. So you can easily move your data from one database to another. So switch is a key feature that table partitioning, we use it a lot. So it makes easy of management large tables, and you can use the switch options to take partition data out of the partition table, and in order to manipulate the data, then pull it back to without affecting the partition table. You can take neighborhooding partitions, the next partitions, out of combined data in one staging table. Let's say we took the partition 3 and partition 4, and we take it out in a staging table. We merge these two partitions, and we switch and we put it back to the partition table as a single partition. So it will be in minutes, it will be very quick. So also the most useful way people use you can move the partitions forward in time by switching out the oldest partitions. So oldest partition, you can archive your data, and you can switch in, you can change the data with the fresher data, with the new data. It will be very, very easy with the switch. To use the switch operations, okay, you may want to use it, but we need to check something on staging data. So at least we should have, for the requirements, at least one of the two tables involved must be partitioned using the partition schema. Also, it is common to refer to the standalone non-partition table as a staging table we can use. So you can use the switch table operation, so switch from the partition of a partition table and empty non-partition staging table. So you need to alter the partition table. So also you can switch from the staging table to empty partition of the partition table. Okay, so in this case you alter the staging table. And the third option is that you can switch a partition from one partition table to empty partition and another partition. So you can use to alter the source partition table. So also you need, for example, for this switch command, the switch table must have the same column structure and the indexes even the same foreign key constraint. All the tables must exist and the destination table or partition must be empty. And if you are switching between two partition tables, the partitions must use the same partition column. So also the source and the targets of the switch must exist on the same file group, so it will be easier. And being on the same file group and it is same database, the switch operations, it will be avoid, of course, we will use this feature as a benefit, it will be avoid and any data movement. So you can, to switch the data out for partition table, so we should create an empty staging table on the same file group as the partition to be switched out with the same structure and including the partition column. And we should create identical clusters, and we may create optionally, we may create an unclustered index on the empty staging table. And also we can optionally, create the check constraint on the standalone table to ensure that all the values of the partition column will be in the same range as the partition that will be switched out, because we are switching out. And check constraint may not be required, as I said, optionally, but as I said, it's a good practice. So we may not, partition column values will, for example, will be accidentally edited or modified. So that would take them out to the original range. So it allows you to switch the staging table back if you have these options to the partition table. You can apply for this switching data out. So you can apply the alter table command to the partition table and add the switch options. So it will identify the source partition, then specify that the switch will be the empty destination table. So for example, suppose on here, you want to switch out partition 2 on table P and empty staging table S. So we should use the command like after table P and switch partition 2 to the table S. here, then it will stage the partition 2. And you can also include the partition of non-partition table, like all tables that you're not in partition schema. And it will only has one partition, numbered 1. For switching data in, and when you switch from standalone table into partition table, and it's vice versa, so the exchange data with the table partitions, you should alter the standalone table, and you shouldn't change anything for the partition table, because this time it is more complex, because standalone table must have the same structure, same indexes, primary key and check and foreign key constraints as the partition table. The table to be switching requires one or more constraints because it can only have partition column values that will match the empty partition's allowable range. So it's a best practice to create the index on the standalone staging table first, then to add the required check constraint, and creating the indexes first allows SQL Server to use the indexes to validate the check constraint. If the indexes are missing, the SQL Server will have to scan the whole table to validate the check constraint. Also, as I mentioned, the target partition in the partition table must be empty. And for example, this code of the table will switch from standalone table, partition table index, and to empty partition for partition table. So it will be switched partition 1 to partition table partition. So I will show you demo again quickly. I'll try to share my screen again. I hope you can see it. Looks like it's working. So I will be showing you demo split. So I will be showing you on demo split. Use master upper database tables. So I am going to add another file group, testdb part 3, to our database. And I'm going to add a new file for the same equations as a part 3. And now I will use the testdb and let's run the partition column to check our partitions. Still, as I add the third one, but it still does not exist because I just put it on, or I just split it with the function, but I didn't put any data in it. So also, as I mentioned, we should use the next used property, next used, and to define this function. And now I'm going to split the partition function and check it again. This is the partition column 1 to 10, and let me insert the values there. And now I inserted to 22, so when I check it again, because I divided for 20 and execute it, say that I can see the partition functions, and when I add the 22, it will be available on partition number 3. earlier than, we would have only two partitions, partition 1 and partition 2, and it would go to this partition. So rolling partition, we have new partition with new row. So to show you the switch operations, I'm going to create the test table archive with the ID, and again, the date I'm not known. And I will create an unclustered index on it, create a unique clustered index on it. Okay. So now I'm going to run switch operations here. So from partition 1 to test table archive. So let me run this one. So it's successful. So it's easily moved, switched my partition 1 data to test table archive. So if you can check this one, you will see that my partition 1 is disappeared, and there are partition 2 and partition 3. And also, if you want to check the test table, you will only see the 11, 12, and the 22 as a value. And if you check this test table archive, you can see that my other data will be in other tables. So it easily, you can move your data easily like this way, only with using this partition 1 to switch from partition 1 to test table archive. So for last, go back now first with the last sentence. I'm trying to go to the quickly, but okay. For the last slide, table partitioning enhancements for SQL 2014. The main is it's mainly two common database maintenance operations in the assessments, and partition switching and online index rebuild operation. So this will greatly increase the enterprise application availability by reducing maintenance downtime impact. So the new feature, one of them is manage log priority. This allows you to manage the priority of the table logs acquired by the partition switch and online index rebuild. So allowing you to initiate any negative performance impact of these log operations or this log on primary workload on the server. And the second good thing is single partition online index rebuild operations. So this feature will allow you to rebuild the indexes online for individual partitions. So it will be increasing the application uptime. So this is also great for large partition tables. And SQL 14 supports 50,000 partitions by default. Also, it was supporting for SQL 2004, but in earlier versions, the number of partitions was limited to 1,000 by default. So in SQL 2014, you can also use the 15,000 partitions on your tables or on your databases. So for the demo and for the presentations, I think I completed, and we just passed 1 minute for the demo. So if you have any question, you can ask, or you can send me an email. My email address is, I think I didn't, it is not here, sibeln@microsoft.com. You can ask me your questions regarding partitioning, and let's see. any questions? If then I can answer your questions. So I think no questions. Okay, so I didn't get a question, and thank you very much for your time, for attending the session, and I hope you liked it. Have a nice day for all.